Hello. In this video we're going to go through dynamic size arrays by getting a user from a specified index and also adding a new user via pushing. So let's move on straight to the UL contract, and here I've already prepared two users for testing purposes, and I've also commented out our previous getAdmin method so that we can have a direct comparison to fixed size arrays. And there's also this method testLength, which you can ignore for now. So let's get started with the getUser. So what did we do first in the getAdmin? Well, we got the slot, and this is exactly the same, users.slot. And now is where things get already different, but also interesting. Since these are dynamic arrays, and their size is variable and thus unpredictable, during compilation, the actual storage pointer is in a different place. And let's go to the docs here, and if we read this, and the elements they contain are stored starting at a different storage slot that is computed using a kcheck256 hash. And this also applies to mappings, by the way. I will leave this link in the description. Let's come back to our code. So we know now that the storage pointer, in order to get it, we need to run a kcheck256 on something. So let's create a new variable, storage pointer, and let's give it kcheck256. And what do we want to pass it? Well, we want to pass it this slot actually. But the kcheck256 actually works as a return statement. It takes a location in memory and a size. And if you haven't guessed it, well, we need to store this slot in memory. So we would use mstore, and let's use the 0x40 slot and store it here. And now we can use this in the kcheck256 and start from the 0x40 slot with the size of 0x20, and that is it. And now this is actually the storage pointer of this array. And from here on, things are actually going to look very similar to the getAdmin array. What do we need to do? Well, we need to get the index slot. And the index slot, here we added to the slot the index. And we're going to do the exact same thing here, except that this time we're adding it to the storage pointer. And actually, these next three lines are exactly the same. We are just going to type them again. Let's get the index value by loading the index slot. This is great for practice, by the way. We're going to store at the 0x40 memory pointer the index value, and we're going to return it just like so. And now we are done with the getUser. Let's test it out. And if I'll run a getUser with 1, I should get this address. Let's try it out. And as you can see, this is correct. And we're done with the getUser. Let's move on to the addUser now. So what can we copy from here? Well, we know we will need the user slot again, and we know we will need again to get the storage pointer. And that's about it if you think about it. So let's copy paste these three lines. Let's move them here. And now what we need to do is we need to store this new user somewhere. And where do we actually want to store it? Well, we want to store it at the end of the storage pointer. But there is a problem. Where is this end? Well, the next slot is basically the length of this array. But the length can be 5, it can be 100, we don't know. But there is a way to do it. And this is where this testLength method comes into play. In order to get the length of a dynamic array, we can use sload on the slot. And let's try it out. If I run testLength on this array, I should get 2, right? And I do. So we can get this line here. Well, put a let in front of it, just like so. And now we have our length here. And coming back to what I said, we need to store at the end of the storage pointer the new user value. So in order to get this to get to the end of the storage pointer, we would use add, and where the storage pointer is, we would add length. And then we need to pass it the value that we want to store there. So this new user. And let's try it out. Let's deploy it. And now let me add this address again, add user. And when I run get user now at index number 2, I should get this user, right? And I do. Now let's double check with users and try this again. And try with index number 2, and oh, what do we have here? This has been reverted. Can you guess why? Well, you probably will not guess, but the reason is that the size of the array hasn't actually been changed. We've only added at the end in memory, at the end of the array in memory, but we didn't change its size. So this users doesn't actually know the new size of the array. So how would we do that? Well, we need to also store the size. So how do we do that? Well, if you remember, this length basically, this user slot is where the length is. So we need where the user slot is to store the new length of the array. And how would we do that? Well, we just use add on this length and add 1. And that is it. So remember, we also need to change the size of the array, not just to add the element at the end. So now let's try it out. Let's deploy it. And if I do the same thing again, I add the user and I get the user from index 2. And now if I try to get the users from index 2, you will see that this works. So we are done with the coding. Before we set off, let's do a quick comparison again in terms of gas, but this time we can't really compare the get user to the in Solidity and Yule, and this is because we don't actually have we don't actually cover the situation in which the index doesn't exist. So it's a bit unfair to compare the gas consumption here, but we can compare the add users, and the add user here in Yule, it's 0.8k, and in Solidity it's 49k. So as you can see, Yule is again better. And that is it. If you have any questions, leave them in the comments or DM me. Thank you for watching, and see you in the next videos.